Alrighty, kia ora everyone. So here is our first and actually only lesson of week number 8 lockdown work. In fact, this is our last chemistry lesson of the year. This is the last bit of content that I need to kind of teach you. Kind of unfortunate that I'm doing this during lockdown, but it means that the good news is that you guys have lots of time to kind of practice and study because you then have basically the last 2 weeks to kind of make sure you understand all this stuff. Because we're in week 8, so I'm thinking week 9, week 10. Anyway, so fun enough for today is we are going to be communicating the observations of a redox reaction and linking it to the species involved and the equations. So basically, I'm taking the stuff that you guys have learned over the last couple of weeks, and I'm showing you how it's going to be assessed and how to kind of use the resources and the template sheet. So let's learn about how to communicate. So basically, nothing off the checklist. We're just kind of integrating everything together that we've talked about. Cool. So what I'm going to do is I'm going to walk you through 2 examples. You used both these examples last week, and I'm just going to basically show you how it fits into the format of this assessment. Do keep in mind that the checklist does include the Achieve, Merit, and Excellence requirements. And what I will be doing is I will be writing, obviously, in those sort of sets so you guys can understand what the exact kind of requirements are for this assessment. Cool. Oh, I want to go there. All right, so let's go to the Google Doc. There, or not Google Doc, the OneNote, so we can write and talk about our answers. Cool. I will do my color code that I normally do. I might actually use the thinner pen now because I have to write in those boxes. But just as a reminder, the Achieve requirements will be in red, the Merit requirements will be in green, and the Excellence requirements will be, the Merit requirements will be in blue, and the Excellence requirement will be in green. So basically you can see how this answer is going to build with the different levels. So, first thing I'm going to be doing is I'm keeping in mind what I'm mixing together. So you have iron sulfate and potassium permanganate. They are mixed together, and the color changes from purple to colorless. So basically, I need to take that information and figure out what is the active reagents involved in that reaction. So let's break this ionic compound apart. We have iron 2+. And we have sulfate, SO4 2-, and then in this one here we have potassium, and we have permanganate. Now I'm writing this down in red for right now, because you're going to need to be able to do this work to be able to answer this question. So I'm basically kind of showing you guys the thought process. So for each one of those reactions, I need to figure out what is the active species involved. So we are going to be looking at my resource sheet. And basically what I'm trying to do is I'm trying to identify who's doing what. Does this have the draw function? Yes, it does. Go away. All right. So we're going to go with pens. So what I'm looking for is I'm looking for my permanganate. Oops. Stop inking. Let's erase that. I wanted to move my screen down. So actually, no, let me go through the whole list. So the first one I'm looking for is iron 2, which I do have on this list. It is right here, and it's a pale green. Now, even though the colors that I have used haven't stated pale green, you probably wouldn't notice it, and that's why I wasn't included. Cool, so that's my first thing. The next thing I'm looking for then when I'm looking at this list is I'm looking for the sulfate. So I do see sulfate there. With the SO4, and that is colorless as well. So that kind of gets me looking at that first bit. The second component then is my potassium. When I look at this list, I can't see potassium on there, so that tells me I'm probably not using the potassium. So we can go back here and cross out potassium. So the next thing I look for then is my permanganate, and I can see it over here, and that explains kind of the purple color that I was seeing. So I know that I must be using the permanganate, but I don't know if I'm using the iron 2 or the sulfate. So in order for me to figure out which of those two I'm using, I'm going to need to look at the redox pairs. So I'm looking at this list, and I'm looking at where permanganate is. permanganate is going to the manganese ion, and it's going in this direction, so this must be my reduction reaction. Because we know everything going in that direction is my reduction. So, there we go. So that's what I'm looking at there. Cool. When I go look to see where permanganate, or sorry, where that Mn2 plus is, I see that it's colorless. So that's now starting to help me explain the color change that I see, the purple to colorless. So I must be changing that permanganate. Cool. So now when I'm still looking at this list, I'm going to look down and I'm trying to see where SO4 is, and I'm trying to see where the iron 2 is. I can see SO4 in a couple of locations, here, here, and here. And I can see iron 2 here, and I can also see iron 2 over here. Now, part of the problem is when I'm looking at these different equations, I need to pick something that's going to be on the right-hand side of this redox pair, because I need one that's going in reverse, because I need to have an oxidation reaction. The problem that I have with everything here on this left-hand side is that all these are still reduction reactions, and I know I can't have two reduction reactions. So that's how I can confirm that I'm using the iron 2. And I hope that makes sense to you guys. So I'm not using the sulfate, we're using the iron and the permanganate in this equation. Cool. So my first step then is I need to state the observations and link them to the redox reaction. So my observations are that the solution goes from purple, and again, we want to link in why is it purple. So it's purple because of the permanganate. If you want, you can also write down permanganate. To colorless. And the reason why it's going to colorless is because now you are forming Mn2+, so the manganese ion. So that's my observation. I have now linked it back to the species. I've met that first requirement. Second thing is I need to identify which is the oxidation and which is the reduction reaction. So this is going to be this bit here. Remember that when I have oxidants, this is the reduction reaction. And when I'm talking about reductants, this is my oxidation reaction. Remember, the vocabulary switches around. So for that reduction reaction, we had that MnO4 minus going to Mn2 plus. And for the oxidation reaction, we had iron 2. Now let's go back to that resource sheet and see what that iron 2 is becoming. Iron 3. So keep that in mind when you're looking at it with the vocabulary. You do need to make sure you have your vocabulary the right way around. If you're not sure, just make that note. Oxidants is reduction. Reductants is doing the oxidation reaction. So then here, you need to talk about what is the oxidation, or sorry, identify the reaction. So this is a reduction reaction. And the oxidant is, and then name the chemical species. You can either write down the formula or you can write down the name. So I'm just pulling that information from over here. All right. Next thing, this here is an oxidation reaction. And the reductant is my iron 2. So basically, if you want to get an achieved, you do need to know your vocabulary. So I have identified which is which. My last requirement for the achieved is linking oxidation and reduction, giving it basically justification. So there's two different ways you can justify it. You either justify it with telling me why it's a reduction reaction, or you justify it, sorry, when you justify it, you can either tell me it based off of the electron numbers, or you can tell me based off of the oxidation numbers. And I only need you to show me one of them, which is great. So it's an or option between these two, but obviously write them in both so that way you still get the points. So you justify this is a reduction reaction. And then you give me because. So because you can say electrons are gained. Or you can tell me that the oxidation number decreases. Both of those are fine. So lots of different ORs options, because when you look at that checklist, you can link oxidation or reduction to gaining / losing electrons, or increase or decrease in oxidation number. So basically, if you had just written this down on the assessment, you would be able to get an achieved on it. You will be given 3 reactions, I believe. No, sorry, I think you're going to be given 4? No, 3 reactions. You need to get 2 out of 3 correct. All right, looking at the other half, do the other half just to be in case. Let's say you forgot your vocabulary, and if you wrote them both down as reduction reactions, gave me the definition, at least one of them's right. All right, so this is an oxidation reaction. Because electrons are lost. Or you can tell me that the oxidation number increases. That's also fine. So lots of different ways to get the achieved, and that's all I need to do. All right. If you want to get a merit, then you need to do some more work. The first thing is to balance the half equations. Second thing is justifying with specifics. And then the third thing is making sure you are talking about oxidation numbers. Be mindful there are ORs again. So with these ORs, you basically need to do it for one or the other. So either you get the oxidation half right, you get the reduction half right. But I need, in both cases that you've talked about, the oxidation and the reduction reaction. So again, you have another OR option. You just need to get one of these 2 boxes completely correct. And in this case, now you're going to be adding extra information. So from previous kind of experiences, you should hopefully, I'm not going to go through the detail, but the manganese oxidation number in the permanganate is +7. So I'm just putting that down there. And then when it becomes the +2 ion, it becomes +2. So first thing I'm looking for the merit is that you give me the specific number of electrons. In this case, the number of electrons will be 5. So I'm just adding that blue bit there. The other thing I would be looking for then, so in this case, it's going to be an and. Oh, sorry, I should specify that. So either you get the electron number right for the oxidation or the reduction, or and you need to get the oxidation numbers correct. So you might, I'm explaining this very badly. Let's just finish the answer. So oxidation number decreases from +7 to +2. Make sure your positive signs are in front, because that's the chemistry language. Cool. In this case, I have my oxidation numbers. This one's really easy because it's just the charge of the ions. You're going from +2 to +3. You're losing 1 electron. And we can change this to is loss. The oxidation number increases, and let's add some more detail, from +2 to +3. Actually, let's add a little more. Increases by 1 from +2 to +3. So we're just going to make sure we're really, really clear that we know what's going on in our reactions. Cool. All right. So as I was saying with the checklist, you need to get the oxidation, the number of electron transfer correct for oxidation or reduction. So either you get 5 or you get the 1. And again, you need to have detail on oxidation numbers. So you need to have both electron number and oxidation number, but you only need it for one of the reactions, and you can't have it as a mixture of the 2. So let's say you got 5 correct here, and you got this bit correct over here. That would be fine. But in most cases, most people will get it right. And you tend to get it right in the same category. So the nice news is that we do have these simple equations with the just the ions changing. And so that will hopefully make it really easy then to answer the justification part. So even if you get it wrong, you don't know how to do oxidation numbers properly here, you would still be able to get most of the merit points from that. Cool. So we've done that, and now we need to balance half equations. Again, there's easy ways you can get merit. So let's say, for example, you aren't very good at redox, you don't know how to do the oxidation numbers of the permanganate, and you don't know how to balance those complex equations. The good news is that you can still possibly get a merit if there are easy redox equations there. So for example, if you could write this down, like that, even though you don't have the second half equation, even if you left this blank, you would still be able to, or I should say just the justification component blank, you're still able to identify the reduction and what the product is. You'll still be able to get a merit. So I just want to kind of show you that it is actually relatively easy to get the merit points even if you don't have everything filled in. The other thing then is to... So we'll tick that off. And that's basically it. But if you want to get an excellence, you need to have the full equation and both half equations. So for the merit, it's an or. For the excellence, it's an and. And that's what I want to kind of specify. So here's my other equation. My other equation would be my MnO4 minus and my Mn2 plus. And we need to have the water there, and we need to have the hydrogen ions there, and, sorry, I was thinking about something else. That's 8, and the electrons. So, either or of those two things would get you a merit, but you're probably going to get this simple equation if you're going to get anything. For the excellence, you need both of them. So I do have both my half equations down. The final requirement is that you put these guys all together. So that's 5 and that's 1. So I'm multiplying this whole equation by 5. So that's going to be 5, that's going to be 5, that's going to be 5. My electrons will cancel out, and then I just write my final full equation down. See how I'm aligning the arrows up? I just do that so that way it's very easy for me to see what's on what side of the equation. So 5 iron 2s plus 8 hydrogen ions plus the permanganate ion, and then on the other side I have 5 iron 3s plus the manganese ion plus the 4 waters, and that's me done. Cool. And that's what you need to do for the excellence. So excellence, you need to have all these components to it. What did I want to add about that? Double and triple check things. Remember how I talked about in previous lessons, you can go through, check the charges on each side of the equation to make sure they're balanced, count the number of atoms on each side of the equation to make sure they're balanced. I would say do that as a final step. Go through and make sure you answered all the questions, because you're going to have 3, and it's going to be 2 out of 3 for your grades. And then go through and double check everything. Alright, so that's that one done. Let's do the second example just to make sure you guys are feeling okay with this. So, in this second example here, we are dealing with, I'm just going to use the gray pen, because I'm going to have to go back to the resource sheet. So we're using acidified potassium dichromate. So when I break that down, I have the potassium ion, and I have the dichromate ion. Now, I already know from what we looked at previously, potassium isn't on that list, so dichromate must be used. The other thing I have is sodium, and I have the sulfite. So again, I need to look at my sheet and check to see which one's on there. So I can see on here, let me find you that dichromate. Here's dichromate, it's orange. And when I look at my sheet, it's going from orange to green, which is useful because then I can use that information to help find what I have. So that's what the orange is. Dichromate, when I look at it, is, I have some options. There's the chromium ion, and there's also chromium the metal. Now, I know it's not going to go into the metal because I see that green is another product. So I know that it's going from here to here. And actually, I can find it on my resource sheet as well. Let's check the reaction. I see that my dichromate is right here, going to the chromium ion, which is green, and that's my reduction reaction. So that already kind of helps me kind of find things. Anyway, let's see if I can find the sodium. Can't, not there, so it's basically I'm not using that one. And so now I'm looking for the sulfite. So that's SO3 2-, and I can find it right here, and it's colorless. Nowhere else on that, nothing else. Or sorry, that's what I'm looking for. All right, now I'm looking on this pairing, and I'm looking to see if I can find the sulfide. Remember, you're looking for SO3, not SO2, and this is actually my only SO3 when I'm looking at that. Yep. So it must be this reaction here as my reduction or my oxidation, and that makes sense because I can see that's going in reverse. So a good hint while you're working is that you should always get one from each side of this table because you can have one oxidation, one reduction. I can see that's forming the sulfate ion, and that sulfate is colorless as well, so that matches. I'm not getting something that doesn't match with my observations. So again, let's go through observations. Let's write that down. The solution's going from changes from orange, again, identify what's the orange. In that case, it's the dichromate. To green, and that green color is my chromium ion. So tie my observations to what's happening. Cool. Now I need to identify which one's oxidation and reduction. I've done that using the resource sheet. So let's pop this down. So I know that oxidants, that is my reduction reaction, so go ahead and fill that in. And I know that reductants is my oxidation reaction, so go ahead and fill that in. So for my reduction reaction, we were going dichromate to the chromium ion. And from my oxidation reaction, we are going from the sulfite to sulfate. So my oxidant is the dichromate, and my reductant is the sulfite. Cool. All right. So last thing I need to do for my achieved is my justification. So just give me some definitions. So you go, this is the reduction reaction. Because it has gained electrons, or you could say because the oxidation number has decreased. Not fussed. Lots of different ways you can show that. In this case, this one's the oxidation. Because it has lost. I'm putting a little space here because I'm just putting in space for me to do the merit. I didn't need that space there. Lost electrons, or you could justify it because your oxidation number has increased. Not fussed. All right, cool. And like I said, it's just an or option over here as well. You just basically need to give one definition. All right, so in order to get the merit now, I need to go through and check oxidation numbers and see how they're changing. We'll just refer back to that previous lesson. So the chromium and dichromate is +2. Yeah, I'm just pulling the numbers. But you guys will obviously do the working. So that one is positive 6. That's to positive 3. That's positive 4. And that's now going to positive 6. Cool. So let's put in justifications. In this case, it's going to be gaining 3 electrons. Now be mindful that I want you to be referring to things as per atom. So yes, there is 6 total when you guys are doing the actual reaction, but that's because there's 2 chromiums there. So do kind of keep that in mind. And that's where you guys can make these silly mistakes that are going to then affect your answer. So oxidation number in this case has decreased by 3, going from positive 6 to positive 3. On the flip side here, this one has lost 2 electrons, and its oxidation number has increased by 2, going from positive 4 to positive 6. That's all you gotta do. All right. In this case, I've given you 2 hard reactions, and so it's going to be more challenging to basically get merit and excellence, because you now need to know how to do the complicated equations and also how to do oxidation math. So let's do the dichromate. Again, 2 minus. Put down the active species first, balance it, and then what we're going to be looking for is adding water, adding hydrogen ions, and then you're going to be adding your electrons to balance that charge. Let me just double check the other one to make sure I've done that correctly. Because I'm doing them very quickly. 14. I knew there was something funny about that. All right. And the second equation, SO3 2 minus, SO4 2 minus. So like I said, or option for the merit. Adding water, adding hydrogen ions, and then adding electrons. That should be the right equation. Just double checking it. Yep. I'm just basically trying to shorthand it so we're not going through all the various steps. I put the water on the wrong side. Whoops. This is why you double check things. Water's supposed to be over here. Cool. All right. Last step then is to put it all together. So or and for the excellence, check your electron numbers and make sure they match. They don't, so I need to multiply this whole side by 3. So that'll be 3 waters, that's 3 sulfites, that's 3 sulfates, that's 6 hydrogens, and then that's 6 electrons. Double check that I did that right. Yes, I did. Cool. Now let's just cancel everybody out. Cool. So as I'm working through this, keep in mind when you're canceling things out, you're looking to see what's on one side of the equation and taking away the others. So that is going to be all removed, and this turns to a 4. All those hydrogens will be removed, and then that's going to turn into a 8. Cool. And then put it all together. Oh, the electrons. Those guys cancel out, so we don't have to worry about them. All right, so here's my full equation then. I'm writing the dichromate. Plus the hydrogens, plus the sulfites, and then the other half, chromium. So basically it's the stuff that you guys were doing last week. I'm just showing you how to put it together. Cool, and that's everybody. And that's what you need to do for the excellence. So if I'm nice, I'll give you an easy and a hard one, so that way you can still get the merit. If I'm really, really nice, I give you 2 easy ones. If I'm really mean, then I give you 2 hard ones. So that's basically what you're looking at for what we're expecting for this write-up. So let's tick that off. Have I identified? Yes, I have. Have I talked about which one's which and why? Yes, I have. Have I did half the equation? Yep. Have I linked the oxidation number to the electrons? Yes. And yep. And then we do the last one, which is balance both equations to the full equation. All right. So that's basically everything that you'll need to do for this assessment. So, Kapai, really good work. Basically, all I want you to do this week is just to practice doing these equations. There's a whole list of practice combinations that you can do that are on the Google site, and I highly recommend that you do them on the template. Otherwise, what was I going to say? Do them on the template. Otherwise, if you guys just want to practice, just look at the resource sheet and grab 2 things and just write it up. Is the other option. I've also hyperlinked a lot of different kind of equation practice stuff. It's basically similar information that they want you to pull. The format of the template's different. So if you want, you can take those questions and just put it onto the template. But make sure you guys complete give this work a go and write any evidence on the week 8 lockdown work. You can either type it or you can take photos. I'll put a practice redox assessment up as well. And yeah, just make sure that both of those things are completed. And then I'll talk to you guys to see what you want to do for week 9 and week 10, because we can do some exam revision stuff, or you guys can keep practicing, and I can give you some more redox practice. I'm not too fussed. If you're in my Google class, if you're in my class, can you please do your week 8 check-in? Same thing as always. The random question for this week is, who is someone you admire and why?